Hello everyone, myself Dr. Sree Lakshmi, Assistant Professor in the Department of AML at Institute of Aeronautical Engineering. In this session, I am going to discuss about Muller's method, which is used to find out the root of the given polynomial. Muller method is a root finding algorithm for finding the root of an equation of the form f of x is equal to 0. It was discovered by David E. Muller in 1956. It begins with three initial assumptions of the root and then constructing a parabola through these 3 points and takes the intersection of x-axis with the parabola to the next approximation. This process continues until a root with the desired level of accuracy is found. Now here, assume any 3 distinct initial roots. The initial guesses can be done as per the conditions. Let it be x0, x1 and x2. Now draw a second degree polynomial, that is a parabola, through the values of the function f of x. For this, we will calculate f of x0, f of x1 and then f of x2. So wherever this parabola touches the root, then when we draw, so that is this root estimation value. So the root estimation is wherever it touches the next approximation value, then this is the root value. So initially x0, x1, x2 taken and the function values are taken. With these 3 values, the initial guesses, we will find out root estimation and then finally we approach the root value, approximate root value. So for this Muller method, some standard equations are there. By using these equations, we will calculate the root or we will find out the root. The first thing is, that is the first step is, once if you assume x0, x1, x2, then it is easy for us to find out h0, h1, delta naught, delta 1, what are all the variables required, we can find out. But these initial guesses, sometimes in the problem they will mention, otherwise we need to consider. And even here, the procedure is same. Always the root value lies between negative value and then positive value. We will approach in the way f of x0 we will find out and f of x1 we will find out and then we will move on to the root value, that is x2. To find out this x2, we have the formula as x2 is equal to x1 plus minus 2c by b plus or minus root of b square minus 4ac. This is the formula to find out the root value. Since here in the formula they taken x1, x2 and x3, so to find out x3 value, this is the formula. But the initial guesses we taken here as x0, x1 and x2, you will move on to this 4th root. So this is same as this, but only the small change is x3 is equal to x2 plus, because x0, x1, x2, 3 initial guesses. In previous methods, that is bisection, regular falsy, secant, Newton-Raphson, in all these methods, we will take only 2 initial guesses and then we will find out the root. But here we need to move on to the 3 initial guesses. So based on the naming, we will select the initial guesses. So consider here 2, the initial guess, x0 is equal to 2 and x1 is equal to 2.5 and x2 is equal to 3. This is our step 1, finding out the initial guesses. And now second step is find out h0 and h1. So with this initial formulas, that is h0 is equal to x1 minus x0. So what is x0 here? 2. x1 is 2.5. So 2.5 minus 2, which is equal to 0.5. This is h0 value. h1 value x2 minus x1. So x2 is 3 and x1 is 2.5, the h value is 0.5. So here h0 and h1 values are 0.5 and 0.5. This is step 2. Now step 3. We need to find out delta naught and delta 1. So to calculate that, we have formulas f of x1 and f of x0 and f of x2 we need to find out. So here we will use that f of 2 in the function substituting 2 cube minus 4 into 2 minus 9. So this value is minus 9. And f of 3 value is 3 whole cube minus 4 into 3 minus 9. This is 6. That is, this is x0 is equal to 2. And this is x1, x2 is equal to 3. And this is x1 is equal to 2.5. That is f of 2.5 is equal to 2.5 whole cube minus 4 into 2.5 minus 9. So this value is approximately 2.6. So we need to check in the calculator. So 2.6 whole cube minus 4 into 2.5 minus 9. So 2.5 whole cube minus 4 into 2.5 minus 9. It is minus 3.375. It is minus 3.375. So this is minus 3.375. F of 2.5 is minus 3.375. So now step 3, we need to find out delta naught. So what is delta naught? F of x1 minus f of x0 divided by x1 minus x0. So here f of x1 is minus 3.375 minus f of x0 minus 9 divided by x1 minus x0. x1 minus x0 is 0.5. And delta 1. What is delta 1? F of x2. F of x2 value is 6 minus f of x1 value is minus 3.375 divided by x2 minus x1 where it is 0.5. So now delta naught is 11.25 and delta 1 is 18.75. So now with these values we will move on to the next. So here we will start the step 1 as x0 to x1 2.5, x2 is 3 and we calculated f of x0 as minus 9, f of x1 as minus 3.375 and f of x2 is 6. Now step 2 we did h0 is equal to 0.5, h1 is equal to 0.5 and now step 3 finding out delta naught and delta 1. Delta naught is 11.25 and delta 1 is 18.75. So that is step 3. Now step 4 we need to calculate A, B, C values. So A is having the formula delta 1 minus delta naught by h1 plus h0. So here delta 1 minus delta naught by h1 plus h0. So using that formula A1 we can find out delta 1 is 18.75, delta naught is 11.25 by h1 plus h0. 0.5 plus 0.5 where this value will be 7.5. Now B value. to find out the B value, there is a formula that B is equal to A plus H1 plus delta 1. A into H1 plus delta 1. A into H1 plus delta 1. So where it is equal to A is 7.5, H1 is 0.5 and delta 1 is 18.75. So this is equal to 22.5. So the B value is 22.5. And now C is f of x2. Whichever value is there, that is f of x2. Whichever value we are considering, then it is C. So f of x2 is how much? 6. So C is 6. Now A, B, C values are there. Now you need to find out root value x3. So x3 formula is what? x2 plus minus 2c by b plus or minus root of b square minus 4ac. This is the formula to find out the next root. Here x2 is how much? x2 is 3 plus minus 2 into c value is f of x2, that is 6 divided by b value is 22.5. Now based on the b value, if it is positive value, we need to take plus sign in the formula. If b value is negative, then you need to take negative value in the formula. Now since b is positive, we are going to take only positive root, not negative value. So 22.5 plus root of b square, that is 22.5 whole square minus 4 into a value is 7.5 and then c value is 6. So after substituting all these values in calculator, you will get the root approximate value is 2.704. Up to 3 decimals I am going to consider. This is x3. This is about first iteration, how you will calculate. This is the first iteration, how you will calculate. Now, you need to move on for the second iteration, where all the values need to be found. For the values, x0 will be now 2.5 and x1 will be now 3 and x2 now it will be 2.704. Now, f of x0 is equal to, for 2.5 we calculated it is minus 3.375 and f of x1 we calculated it is 6 and f of x2, this is x3 taken as x2 here. So we need to consider f of x3. So 2.704 whole cube minus 4 into 2.704 minus 9. So what is the value of this? That we need to calculate. So 2.704 whole cube minus 4 into 2.704 minus 9. So where it is equal to minus 0.045453. We can consider up to 3 decimals only. So now with these three initial guesses, we need to move on to the second iteration. So now again you need to find out h0 as x1 minus x0, h1, x2 minus x1. So x1 is 3 and x0 is 2.5. h1, x2 is 2.704 and x1 is 3. So now here the h values and h0 values need to be calculated, and h0 is 0.5 and h1 is 2.704 minus 3. So this is minus 0.296. So similarly, we need to find out the next values for the second iteration. So here the delta naught value is same as previous case. We will find out delta naught is 18.75 and delta 1 is 20.29. And now A is what? Delta 1 minus delta naught by H1 plus H0. So after substituting the values, the A value is 7.54 and B value is A into H1 plus delta 1. So this is 18.06 and C value is f of x2. Now f of x2 is what? Minus, previously we got 0.0045, right? So now 0.045, no double zero, 0.453. So with these values, we will find out now x3 value, where x2 is 2. Previously it is 704 plus minus 2 into C value 0.0453 divided by B value is 18.06 plus, since it is positive value, we will use only positive. So plus root of 18.06 whole square minus 4 into A value is 7.54, C value is minus 0.0453. So after substituting this, the x3 value will get 2.704. So if you observe carefully, up to 3 decimals, for second iteration and for third iteration, we got 2.704. Up to third decimals, we got 2.704, both in second iteration and then first iteration. So we can conclude that, as the final or the approximate root value of the given function, is 2.704, because here we taken only up to 3 decimals. So 2.704 is the root value for the given polynomial by using Muller's method. This is little bit time taken process because more number of values need to be found based on the x0, x1 and x2, and the content is taken from SS Sastry. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.